Bismillahirrahmanirrahim. Our today's lecture is about Introduction to Limits, in which we will discuss how to solve limiting functions with the help of rules and techniques. Now we are going to discuss the rules, formulas to find out the limits. So the first formula for this is number 1, limit of constant function is always same or constant. So mathematically we can write it as limit x approaches to a, f of c is equal to c. So before going further to solve any other example, I would like to explain this formula in detail. So this thing which I have marked, limit of function x approaches to a is the value of variable x after some time f of c is constant function, and c is the result after applying limit, which is always constant value of function. Now we take an example. For example, limit x approaches to 3 and 100. Now x approaches to 3 is the limit of the function and 100 is the value of the function, which is constant. Since the function is constant, so its value will remain same, so we can simply put 100. It simply represents the formula limit x approaches to a, f of c is equal to c. This is the limit of the function, this is the value of the function, and c is our result, which is 1. Similarly, we can take another example. For example, any constant function, limit x approaches to 2, and we can take a universal constant pi. Since universal constant is also a constant function, so its value will always be same, which is pi, which means any function whose value does not change will remain the same. We can take another example. Limit x approaches to minus 10 2 pi. Now again it is a constant, so its answer will be 2. So these are few examples regarding the constant function. And now another formula. Now we consider another formula, which is number 2, constant time function. Constant times function. Constant time function means any constant which is multiplied by the function. Time means function. So the formula is limit x approaches to a k f of x is equal to k limit x approaches to a f of x, which means any constant which is multiplied by the function is first of all taken outside the limit. As we have taken this k outside the limit, this function is taken outside here. So this is the function which is constant time function. Now it will more clear when we take an example, as for example limit x approaches to 3 5x. Now 5 represents k and this x is f of x. So first of all we can write 5 limit x approaches to 3x. Now we are going to apply the limit simply, which is 5 3, and when 5 is multiplied by 3 is 15, which is the answer. Now one thing also very important, that when we apply the limit, which means that we have applied the value of the limit x equal to 3 in this function, the limit we will not write. If you write the limit again, this will be wrong. So as another example, we can write it as another example. This is your example number 1, and this can be treated as example number 2. So limit x approaches to minus 2 10x square. So we are going to apply the limit. So 10 limit x approaches to minus 2 x square. 10 minus 2 square is 10 multiplied by 4 is 40. This is your answer. Now we take another formula, which is commonly known as power rule, which is power rule, and it is limit x approaches to a x raised to power n is equal to a raised to power n. In this formula you can see that x approaches to a, the value of x is replaced here in x, and n is any where n is any positive integral value. It may be 1, it may be 2, 3, 4, any value, but not a negative value will be considered here. So as an example, limit x approaches to 2 x raised to power 3. Now this is our example 1. Now if we compare with the formula, this is x raised to power n and this is the limit which is x approaches to. So putting the value of x, we get 2 whole power 3 and cube of 2 is 8, which is your answer. This is the example. Now we can take another example. For example, we can consider as example number 2. Limit x approaches to 3 6x square. Now this is the combination of the formula that we have studied previously, which is a constant time function. So first of all, we are going to apply the limit for the constant time function. So 6 is taken outside and limit x approaches to 3 x square. Now we are going to apply the limit, which is 3 square, and the square of 3 is 9. 6 9s are 54 is our answer. Now we take another rule which is commonly known as sum rule. Sum rule. This rule actually states that when two functions are added, how we apply the limit to them. So limit x approaches to a, f of x is one function plus g of x is another function. Now we are going to apply the limit. This means that limit is multiplied by f of x and the limit of the function is multiplied by f of x. We get limit x approaches to a f of x plus limit approaches to a g of. After this, we can apply the limits to these separate functions accordingly as per the formula or requirement of the question. For this, we are going to take one example. For example, I am marking it as 1. Example number 1. Limit x approaches to 2x plus 3. Now if we see this formula or question exactly represents the formula, that is 2x square represents f of x and g of x represents 3. So we are going to apply the same criteria as above. Limit x approaches to 2x square plus limit x approaches to 2 and 3. We can compare this thing, f of x and g of x. Now here in the question there is 2 which is a constant, so applying the rule that was constant time function. So 2 limit x approaches to 2 x square plus. Now here is 3, there is no variable here, so it is a constant function. Therefore we have already studied the limit of a constant function is same, so answer is here 3. Now applying the limit 2 square plus 3 2 4 plus 3 is equal to 8 plus 3, which is 11, and this is your answer. Now we take another formula which is commonly known as product rule. Product This means that whenever two or more functions are multiplied, how we will apply the limit. As a rule, we will generally take only two functions to solve the problems. So limit x approaches to a, f of x is one function, dot means multiplication, and g of x. Now in this formula, the same case, we will apply the limit with f of x and with g of x. So the formula will become as limit x approaches to a, f of x into limit x approaches to a, g of x, which means two functions are being multiplied here. So we take an example, which is example number 1. Limit x approaches to 3, 2x square plus 1, dot means again multiplication, 4x. Now if we see this question, f of x represents 2x square plus 1 and g of x represents 4x. So this limit will be multiplied by 2x square plus 1 and limit x approaches to 3 with 4x. Limit x approaches to 3, 2x square plus 1 into limit x approaches to 3, 4x. Similarly g of x and similarly f of x. Now we will apply the limit individually to both of these functions. So limit x approaches to 3, 2x square, applying sum rule here also, plus limit x approaches to 3, 1. Now I'm going to put the bracket here so that it should remain separate from the other function. Now 4x in this function is constant, so 4 will be taken outside. Limit x approaches to 3, x, here again 2, limit x approaches to 3, x square. Now limit of a constant 1, which is 1 again, so we'll remain the bracket here as into 4, 3. So this will be 2, 3 square plus 1 into 12, which is 2 multiplied by 9 plus 1 into 12. So 2 9s are 18 plus 1 into 12. So our answer is 228. This is the answer. So in short, we can say that we can take different questions, examples with the application of all the formulas that so far we have studied. Now I am taking the next rule. This rule is commonly known as division rule because we divide two functions, and how we can apply the limit here. So we apply as division rule. Limit x approaches to a, f of x over g of x. Actually, in division rule we split the limit to the numerator and denominator value. So limit x approaches to a f of x whole divided by limit x approaches to a g of x. Now we consider an example which will be more easier to understand. 1. We have a function limit x approaches to 2, 2x square plus 5 divided by x plus 1. Now this is a function of Dewey function, so we will write limit x approaches to 2, 2x square plus 5 limit x approaches to 2, x plus 1. Just scrolling the screen upward. Now applying the limit in the numerator and applying the limit in the denominator, we can see limit x approaches to 2, 2x square plus limit x approaches to 2, 5 limit x approaches to 2, x plus limit x approaches to 2, 1, 2 limit x approaches to 2x square, and limit of constant function is constant, so it will remain constant, which is 5, 2 plus 1, 2, 2 square plus 5 whole divided by 3, which is 2 multiplied by 4 plus 5, because the square of 2 is 4 whole divided by 3. We get 2 4s are 8 plus 5 whole divided by 3, and 8 plus 5 is 13 by 3. This is your answer. It's better to remain in fraction other than you are divided. Now the last formula for limits is when we have a radical sign over the function. Limit x approaches to a under root f of x. This is the radical sign. So in simply we will write the limit inside the radical sign and apply the other formulas if they need it. Now as an example number 1, as one example I am going to take, because in further practice we will encounter more problems for that. So limit x approaches to 2 under root x square plus 2, taking the limit inside the radical sign as the formula requires. Limit x approaches to 2, x square plus 2. I am extending this line of the radical sign. So limit x approaches to 2x square plus limit x approaches to 2, 2. So 2 square, and 2 is the constant, and we'll put the radical sign here. So 4 plus 2 under root 6 is your answer. So this is the formula for applying limit when there is the radical sign. Dear students, for today I am completing the lecture in which we have only studied few formulas which are applicable in our coming problems, and with one question or two questions for each we have solved. In next lecture we will start solving the exercises of different techniques for the problem. Also, please subscribe my channel and press the bell icon so that you can receive further updates. Thank you.